Hello friends, this video on Work and Energy Part 4 is brought to you by examfear.com. No more fear from exam. Let us, now that we have talked about what is work, what is energy, what is kinetic energy and potential energy, let us talk about the law of conservation of energy. This is very, very important because it is a universal law and it holds true in all cases. Law of conservation of energy tells that energy can neither be created nor destroyed. It can only be converted from one form to another. It says that irrespective of whatever process or whatever event takes place, energy will never get destroyed. Neither we can create energy. So energy will always get converted from one form to another. For example, I talked about so many different forms of energy: light energy, sound energy, heat energy, potential energy, electrical energy, kinetic energy. So during different processes, different types of energy get converted into other forms, but they are neither created nor destroyed. So that means the total energy in a system will always remain the same, right? Let us look at the example. Let us look at this beautiful example where an object is falling freely. So all of you are aware of what is free fall. In our previous lesson, I talked about free fall in detail. That means when an object is falling freely only under the action of gravity. For example, this ball. When this ball is allowed to fall from the top of the building, it is only under the action of gravity. So the ball is falling freely under the influence of gravity. Right? Now let us call this point as A and let me call this point as B. Right? Now here we will see how the energy changes as the ball moves from point A to B. So what happens at point A? When the ball was at point A, what was the energy? What was the total potential energy in the ball? The potential energy was maximum because the potential energy is by virtue of height and potential energy is given by mgh. So at this point the height is maximum. So the potential energy was maximum. And what was the kinetic energy at this point? Kinetic energy was 0 because the ball is at rest. So potential energy was mgh and kinetic energy was 0. Fine. Now let us assume at any point, now as the ball starts falling, it passes through this length, right? So at any point between A and B, so at any point between A and B, what happens? Now as the ball starts falling, the potential energy keeps decreasing. That's because the height is decreasing, right? Initially the height was h. When the ball reaches here, the height is only this much. Again, when the ball reaches here, the height is this much. When the ball reaches here, the height is this much. So as the ball is falling down, the height is decreasing and therefore the potential energy keeps decreasing, right? But this potential energy is some non-zero value. It is less than the maximum value, but it is some non-zero value. What happens to the kinetic energy? Initially the ball was at rest at point A. As soon as it falls, the kinetic energy keeps increasing because its velocity keeps increasing. So now what happens? So here at point A, what was the total energy? The total energy was mgh. So now the potential energy has decreased, but the kinetic energy has increased. Right? So that the total energy again remains the same. So the total energy here and the total energy here remains the same. Now what happens at point B? At point B, potential energy becomes 0 because height becomes 0. The object is on the ground. What happens to the kinetic energy? Kinetic energy is maximum. So what is the value of maximum kinetic energy? It is half mv square. So what do we conclude? We concluded that the total energy at each of these points remain the same. Sometimes the total energy was entirely potential, sometimes the total energy was entirely kinetic, sometimes the total energy was partly potential and partly kinetic. So we can see that in this case what actually happens is that the potential energy of the ball gradually gets converted into kinetic energy by the time it reaches the ground. So throughout we can say that the total energy of the object is mgh plus half mv square remains constant. So kinetic energy plus potential energy remains constant. right? So you now understand what is the law of conservation of energy. Let us look at some of the other examples. What happens when you switch on the fan at your home? When the fan is switched on, the electrical energy gets converted into the kinetic energy of the blades of the fan, right? So when we switch on the fan, it is not that the electrical energy gets wasted. The same electrical energy is getting converted into the kinetic energy of the blades. Similarly, when you switch on a light bulb, the electrical energy, it's getting converted into light energy and heat energy. Similarly, if we take the example of the windmill, what happens in the windmill? As wind blows, these blades of the windmill starts rotating. So the kinetic energy of the blades of the windmill gets converted to electrical energy. Similarly, in hydroelectricity generation, the example which we talked about some time back, here also the kinetic energy of the flowing water is used to rotate the turbine and therefore generate electricity. So here also kinetic energy is getting converted into electrical energy. In fact, here the water is stored at some height, so the water has potential energy. So the potential energy of the water gets converted into the kinetic energy of water, which in turn gets converted to the electrical energy or electricity. So this is what is conservation of energy. That means energy will always, during any event or any process, energy will get converted from one form to another. It can neither be created nor can it be destroyed. Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.